Just trying to make sure. Hi, everybody. Good morning. Thank you for coming to my session today. I'm really excited to really turn this into more of a interactive conversational discussion, in addition to me sharing some insights and lessons learned from working with my organization over the past few years. So just to get started, I figured I'd tell you a little bit about Pandata and what we do so you understand where I'm coming from with this story. We are a design and development firm that helps organizations build AI-driven solutions. We work with a lot of really cool and exciting innovative organizations, and we really are focused on being approachable, developing tools that are human-centered in design, and infusing ethical data science into all that we do. My ask for you is that as I'm going through this presentation, if you have thoughts or experiences or perspectives that you want to share or chime in, please do so in the chat channel. I also encourage questions throughout. I think we'll all get more out of this together as we're having a dialogue over this important topic. And I can't really start a discussion about ethical data science without first trying to at least define it. And part of the challenge is that we don't yet have a uniform definition in our industry over what ethical data science looks like. But in most cases, you'll see these four kinds of pillars that all rest on a foundation of trust, starting with transparent and explainable AI. There have been a lot of great sessions in ODSCE so far talking about some of these advancements and ways to start turning more black box techniques like neural networks into more interpretable solutions to help humans develop trust in the results that it's arriving at. There's another notion of privacy preserving components to machine learning, both in terms of protecting the identity of individuals when we're building and training models, but also preventing reverse engineering of the outputs of models to unintentionally uncover personally identifiable information. There's a lot of great research and standards going on here. The cybersecurity community has been making a lot of advancements here. The two where I see that there's a great degree of uncertainty and not yet a lot of consistent work on are in terms of maximizing human value and fair and inclusive AI. When we talk about maximizing human value, we're talking about not just, as we rush to automate many capabilities and tools, sometimes we need to take a step back and understand what's the balance between automation and augmentation, and what are some new roles that we're actually creating through AI and begin preparing for that. And in particular today, what I want to focus on is fair and inclusive AI. As I'll talk about in a little more detail later, there are a lot of different definitions here and a lot of nuance here, and it's an area that I'd like to explore a little bit more. So that being said, oftentimes I hear organizations approaching ethical AI as a matter of risk management. I'd like to make the case that it's not only a component of risk management, but it's also good for business. There's a great study done by Capgemini Research Institute in 2019 where they were surveying attitudes and perspectives from consumers that are increasingly interacting with AI-driven tools and automation. In fact, more than half of consumers were more likely to purchase from organizations that they perceived as having ethical practices as it relates to building and deploying AI solutions. And on the flip side of that, up to 34%, so 1 in 3 consumers would stop interacting with an organization as a result of an ethical issue or encounter that they perceived was unfair by interacting with that organization. And if that doesn't have you already caring, there's a mounting number of cases where the stakes are high and hard to spot of AI gone wrong. And just to list a handful of these from the past couple of years, starting with Amazon, considered a leader in this space. They were trying to find ways to infuse machine learning into recruiting. And they developed a model that would be able to, that looked at historic hires over the past 10 years to try to identify which candidates would be most promising to look at. Now, the problem here is that the majority of their engineering hires over that last 10-year period were actually male. And they tried to blind the algorithm unsuccessfully because there's a lot of bias that actually finds its way into the way phrases of speech, and also the way in which organizations might be listed, like an extracurricular like women's chess club, for example. This was actually a really hard issue for them to solve for, and ultimately they decided to scrap the project because they couldn't address the issue of bias within the models. Another great example is by a favorite thought leader of mine, Joy Bolwamini. And if you don't know her, she's really well known as a data science researcher. And one of her great projects in the past year was looking at bias in facial recognition algorithms. Whereas gender misidentification happened less than 1% of the time in males, it happened in 35% of the time with darker skinned females. And this wasn't just limited to one facial recognition algorithm. This was across many leading algorithms. And just to put that in a different perspective, the technology that we're all so familiar with that's available in iPhones to unlock using your face doesn't work as well for our Black female colleagues. And that's something that's really important to keep in mind. And then this last one is actually really nuanced as well. And it doesn't have anything to do with language generation or even facial recognition. This was just based on historic patterns of care. In fact, algorithms are fast becoming a key part of healthcare, and these technologies are now being used to screen somewhere between 100 and 200 million patients a year. That's a lot of individuals. What happened here was an algorithm that was being designed to try to detect which patients who had been into urgent care were most likely to be readmitted, to prioritize them for extra intervention. And there, ethnicity wasn't a part of the model. However, historical patterns of care were, and historically, Black patients had less access to care in the sample that they were looking at. And what ended up happening here was, for equally sick individuals, a Black patient got a less risk score than a white patient, effectively putting white patients ahead in line when it came to this algorithm. So the stakes are high, they're very real, and they're often hard to spot. And increasingly, data science and AI-driven applications are leveraging unstructured data. Just a handful of examples that are starting to gain in popularity are natural language generation, where you can provide prompts and sentences and it uses it to complete content. This is really powerful for expediting the creative process, but can also be a source of fake news. I've seen some really cool fronts. There's a great company called Pattern 89, if you haven't heard about it yet, where they're doing machine learning on creative content and ad creations and ad images to try to predict which features might be more or less successful in resonating with varying different audiences. And then there's the image recognition stuff, which we just talked about, and a growing body of work in audio to text transcription that's being used to derive insights in contact centers. And if you'll indulge me for just a moment on this chart that I know is not very mathematical for you data scientists, but if you were to imagine the x-axis on the bottom talking about the complexity of the goal that we're trying to achieve, where the most foundational analytical goal might be measuring or detecting whether or not a feature is there or exists, and increasing in complexity to the generative creative content like language generation or even interactive chatbots. And then on the y-axis over here, you have increasing complexity of data, starting with basic spreadsheets and tabular formatted data, going all the way to the most complex, larger data sets that include audio, video, images, and larger scale data. There's this plane that exists here, where the further top right you move with your use case, the harder it is to spot data quality issues and the harder it is to spot potential biases. And this is where we start getting into trouble. And I want to illustrate this through a handful of examples. Word vectors are a really powerful tool for natural language understanding. What it allows us to do is take language and turn it into a coordinate system where we can do some really useful things like this. we can group titles or concepts into buckets. And you can see the buckets that pulled out here. We have a grouping of military titles, a grouping of engineering and industrial titles, academic titles, and arts and entertainment titles. This is really cool because it means that we don't need to search for individual words when we're trying to understand or build models that understand context. We're able to identify things that are close enough or very related. And these models are trained on billions of documents that are either scraped through the web based on historic news articles or other sources. And if we think the last 10 years or 20 years of human-generated content is not inflammatory, then we're not looking, and yet we're using this content to build models. So here's a food for thought: sentiment analysis, which is a really common technique that's now being leveraged in contact centers, customer satisfaction surveys, and even internally facing employee satisfaction results. This one study led by the National Research Council of Canada tried to look at, they evaluated over 200 different sentiment analysis systems. So these are APIs. Chances are you've probably used or encountered one of these at some point if you're working in this space. And what they did was they took a variety of these sentence templates that were person, name, feels, emotional state. They introduced a variety of neutral sentences that include individuals' names, and then they came up with a list of historically African American names that were both male and female, and historically European Caucasian names that were both male and female. And what they proceeded to do was swap in varying different combinations of these names in these sentences. And the study had some really alarming findings. More than 3/4 of these systems had some amount of either gender or racial bias or both. What ended up happening here is feminine names in the same sentence, right? Same sentence, same phrasing, same emotional word. The only difference was using a feminine versus a masculine name resulted in higher levels of anger or joy. And when using African American names in the same sentences, it resulted in higher levels of anger, fear, and sadness. Sometimes we think that the bias comes from the context around the words, but when our sentiment systems unintentionally assign negative or charged sentiments to names because it's picking up that these names belong to specific ethnic groups, this is where we start getting into trouble. And another demo, just to show you something that's out there by the Allen Institute for AI, affectionately known as AI Squared. It's a nonprofit research institute that was founded in 2014 with the mission of conducting high-impact AI research and engineering in service of the common good. What they did here was explore one of the newer models that's being leveraged in language creation. For those of you who might be familiar with it, it's called BERT. And they built a question answering model, and they used a really interesting approach where they try to ask underspecified questions. So they're questions that are not answerable directly by the paragraph that's being written, and they wanted to see what would happen as a result. And if anybody wants to participate in the chat, what do you think, based on this first example, the person over the swing is Angela, sitting by the side is Patrick. And the question, who was an entrepreneur? Can anyone take a guess at what the answer to this question was based on this algorithm? And I know it's hard because I can't see the chat right now, but I'll wait another 10 seconds or so. All right, well, just to kind of share what the answers were, in the case where it was asking a question about who was an entrepreneur, even though entrepreneurship was never brought up, the algorithm answered Patrick. In the case where it talked about an Asian woman taking classes with a Caucasian woman, the Asian woman was identified as the bad driver. The same was true with negative stereotypes applying to religion and nationality. Once we start getting into these more unstructured use cases, we need to deeply question how bias and fairness manifests itself in terms of the algorithm's performance. So here's how data and bias sometimes enters the AI lifecycle. We have three potential sources of data. We have third-party models that are these sentiment tools and APIs. We have humans creating data, whether it's through their behavior or through generating content, and then we have machine logs. These are all often fed into data repositories where we're training models, producing insights, generating business intelligence reports or automated solutions that sit on top of these models. And one of two things happens. Either we learn that the model doesn't work and we need to improve our modeling process and go back to the beginning, or it results in behavioral changes, which in turn reinforce the nature of the data being created. When we create changes in human behavior, we can actually reinforce some of these biases. And just some examples of pre-trained data sets that are frequently leveraged in AI-driven projects are sentiment, language models, image classifiers, and entity recognizers. The virtuous cycle of AI solutions, also known as the AI flywheel effect, was originally popularized by Andrew Ng, another great thought leader that I recommend following. And while this is generally presented in the context of product, it also applies to internal solutions that are enabled and aided by AI. The premise is really simple but effective, and it's this notion that as you repeat a process, or as a product is used more often, you're generating more data, you're observing more patterns, and you can use that to create stronger, better models that result in even more effective processes. And the cycle continues, and you can create richer and richer data sets. But if we're not careful, this is what happens when the virtuous cycle of AI solutions actually amplifies bias. You're creating more biased outcomes, which is creating less fair models, which is resulting in less fair processes. So with that being said, I want to invite a little bit of discussion now on how you might define fairness in your organization. So if anybody wants to chime in the chat, I'd love to hear how you've been defining this in your organization. The notions that we have of fairness today stem from two concepts that came out of the 1972 Equal Rights Amendments, and it's this notion of disparate treatment versus disparate impact. And I really like this graphic here to try to explain what inequality is. And it's this idea of there's a tree that's leaning heavily to one side with a lot of fruit on one that's easy to catch, and then the other individual on the other side doesn't have access, and it's not as easy for them to catch the fruit. So does equality look like this, where we give each of these individuals the same size ladder and say, okay, we've treated these individuals the same? Or do we, when we say fairness, are we talking about equity, where we give each individual a slightly different sized ladder to be able to access fruit more easily? Or are we actually talking about justice, where we're fixing systemic challenges in the system to now provide equal access to the fruit on both sides, where we don't need to have different sized ladders? And to get a little bit more specific, I want to talk about a handful of definitions for fairness and how we might apply them in context of machine learning through a toy example. The pizza delivery app service called Slice surveyed 34,000 people in 2017 to put a great debate to rest about whether or not pineapple on pizza is an acceptable topping. And I was very sad to learn that 54% of individuals hate pineapple on pizza. So to take this concept of fairness that we might be familiar with is this notion of demographic parity. If the broader population of individuals can be split on something that's inconsequential, like their liking of pineapple on pizza, then the way this is typically applied is if the minority group is selected at least 80% as often as the majority group, then we can still consider this fair according to demographic parity. And so if company A hires at least 37% of individuals who love pineapple on pizza, we would say that this organization is behaving in a fair manner. Pretty straightforward. The reality is circumstances are often a lot more complex than that. So let's add something more into the mix here. 36% of the US population is college educated. And the reality is you're never going to have a perfect balance in different groups due to different conditions. Let's say in our example here, people who hate pineapple on pizza hate it because they have more refined tastes and they have more access to college. 48% of them have an undergraduate degree, whereas people who love pineapple on pizza only are 22% with a college degree. The notion of equalized odds will say that of the proportion of individuals, thank you, Michelle. I agree. But the notion of equalized odds here says that of the proportion of individuals that are college educated in each group, as long as when we hire, we select the same proportion of individuals from each group, we are now behaving in a fair way. So this is what it looks like. If we are company A and we have 100 candidates and we choose to hire 35, and we select 11 of the individuals who are college educated and love pineapple on pizza, we've now selected 50% of those with a college education, and we now select 24 individuals who hate pineapple on pizza. That is also 50% of the college educated group. Very quickly, we'll notice here that 11 people who love pineapple on pizza is only 31% of the total hires, which is less than the threshold that we set as a fair organization based on demographic parity. And already in a very simple toy example, we find a situation where the two different definitions of fairness can't be reconciled with each other. Dr. Arvind Narayanan is an associate professor of computer science at Princeton. And I'm not gonna bore you with 21 different definitions. I highly recommend watching this tutorial. It was a really eye-opening experience for me. There are more than 21 different ways that we can choose to mathematically define fairness. And as it relates back to this notion of what do we mean by being fair, it really depends on the use case. And that means that data scientists often need to handle these questions on a case-by-case basis and need to recognize that ethics is a process and not a checklist. We can't program it away into our algorithms and assume that it will be solved for. And to go back to this graphic that I shared earlier, it becomes harder and harder to detect fairness and solve for fairness in that higher quadrant there where we're dealing with more complex goals and more complex data sets. If that doesn't already have you a little bit terrified, data science struggles with diversity. Fewer than 11% of data scientists are women. Fewer than 3% of them are women of color, and fewer than 9% of them are people of color. And this matters if we are saying that the definitions of fairness are highly subjective and require diversity of thought and diversity of perspectives to solve for, yet our teams are fairly homogeneous. It makes it really difficult within our own circles to try to solve for these problems when we don't even have the awareness or demographic or ethnic parities to be able to solve for this insight. So that's something that's really important for us to consider and learn to rely on and reach on outside of our groups. I want to take a sidestep here and talk about Pandata's core values really quickly. Basically, these are the characteristics that we live and die by. We hire our team by it. Each one of our interview questions is mapped back to a core value. We evaluate by it, and we celebrate them regularly. And I'm not going to walk through all of them, but one in particular that is really important to us is this notion of navigate ethics. And we choose the word navigate ethics not because we acknowledge that we do the right thing. In fact, it's something that's a little bit more difficult than that. We say Sometimes doing the right thing is unclear, or there may not even be one right answer. So why this matters is during the pandemic, when we all went virtually, we were struggling with our culture, just like any other organization. And we invested in this tool called Bonusly, which basically we can use to shout out and call each other out on doing cool, awesome things. And we tie it back to one of our core values. This has been a really great tool to build morale, but it's also given us some insight into how often we live our core values. I would argue that be approachable is probably our dominant trait. That's the value that we celebrate most often. But I charted out how we were calling out these values over the last 12 months. And what you'll notice is navigate ethics is less than half, called out less than half as often as be approachable, and a really small fraction of the total amount of times that we've celebrated each other as a team. Fun fact, you can see that at the end of 2020, things got really depressing, and so we stopped celebrating as often. But what happened here is this gave us a tool to take a step back and ask the question of, why are we not celebrating navigate ethics as often as our other core values? And that started a really important conversation. And in other organizations where we've had similar discussions, I'll get a variety of answers that sound something like this. We're not building solutions that deal with life or death situations. We're not building self-driving cars. I don't feel confident enough in my ability to discuss or have informed conversations about fairness, equity, and inclusion. And even as someone who's talking about this right now, I identify with that statement a lot. It's not an easy thing to talk about, and it's not often readily apparent what we need to talk about. What was interesting, though, is finding this insight of the fact that we weren't celebrating it as often allowed us to start trying to understand how we can have more conversations about ethics within our own organization. And just food for thought. Most organizations will have KPIs for things like on-time completion, profitability, and in cases where risk is high, count of adverse or risky events might be included as a KPI. How many organizations are counting the number of times meaningful dialogue around ethics has occurred? It was really eye-opening, and sometimes as organizations, we try to jump to, okay, we need to solve for this. There's unintended consequence happening. How do we solve for this? But maybe the foundational level is acknowledging that we're not having the right conversations and facilitating more open dialogue and more discussion on how to handle, how to even start identifying where risk might be. And just to take a page out of regulated industries. For anyone who is involved or aware of healthcare and life sciences, whenever a study is conducted, there's this thing called an institutional review board. And the idea is it doesn't matter if it's as high risk as treating patients live, or as low risk as we're going to take a look at medical records from the past 5 years to do a statistical analysis to see if there's a pattern or trend. Every single use case goes through an ethical review process. And as we know in the data science world, our advancements are evolving faster than regulation can keep up. I think we could benefit a lot from instituting these standard ethical reviews as a part of every project, even when we're not building self-driving cars. So I know this was a really overwhelming intro to issues and examples of fairness and how we've dealt with it as an organization. I know it was overwhelming for me, but I'd like to recommend and leave you with a handful of these resources that I found really enlightening in my exploration of the topic. We're just getting started at Pandata, but we're having conversations more regularly, and that's allowing us to open our eyes and build more confidence to have these types of conversations, both in terms of our organization, but also with our clients and peers in the industry. The slides will be made available to everyone and have these resources attached to it. That being said, I'd love to open the floor to some dialogue or questions. And thank you so much for attending and showing up and being part of this really important conversation.
That's wonderful. Thank you so much. Let's wait for any questions to pop up.
Well, open invitation in case we're not having questions right now. I love to discuss these sorts of things. I love to learn from others and other organizations. Please connect with me on LinkedIn if you'd like to continue the conversation. And a shout out for Pandata to any candidates or junior data scientists in the room. We do have openings and we're hiring and we're growing. If any of this sounds interesting and resonates with you as a way of working, please check us out.
That's wonderful. We have a few questions.
Okay.
First one is from Kyle. Ask, how can data science have an active role in combating inequity?
That's a really great question. I don't think that we have any compelling answers to that yet, Kyle, but I think a big part of it is recognizing that our teams today are very homogeneous. And so that means that when we're having these questions and we're having these conversations, we need to reach outside our circles and talk to professionals who are not data scientists. In my experience, organizations that do this well have data scientists that are frequently talking not only within their own circles about how to solve this, but with other cross-functional teams across the organization, and making it okay for them to be part of the conversation and increase their confidence in being part of the conversation.
All right, so we have another question from Julie. She asked, how are other organizations represented here responding to ethical challenges?
Can you repeat that question one more time?
Yeah, sure. How are other organizations represented here responding to ethical challenges?
So in most cases today, I'm actually starting to see a growing trend of organizations making this a priority and actually creating rules related to trusted or ethical AI. In fact, some of the well-known tech firms like Apple, Google, Facebook, Microsoft have entire teams dedicated to fair and ethical AI. I would really recommend checking out the Allen AI Institute. They have a lot of eye-opening tutorials about how they've been poking around and solving for identifying potential biases, especially in these unstructured models that deal with images and or language. And I think it's a great thing that organizations are starting to spin up teams around this to make it more of a priority to not only facilitate conversations, but also develop interventions. I think we're very early in the industry and trying to solve for this. But what's exciting is it's a good time to get involved today, because any little impact you make today will be a part of the solution.
Awesome. We have a question by Martin Mas. He says, since the world is still full of a lot of unfairness and discrimination, this means the data is also unfair by its nature. So how could we prevent models to become biased or unfair when, for example, training models to predict behavior from some public data?
That's a wonderful question. And I think that's something that we all need to acknowledge. When we're using public data, that is the risk that we assume. I think the default assumption, to your point, is any data that we curate just by scraping and pulling it from public sources, it's going to have bias embedded in it. This is actually really creating a shift in the industry and creating a new type of job, whether it's called data curator or trainer. There are a lot of really interesting opportunities here where we're cultivating and training individuals to cultivate and create labels and sift through this content to create these refined, trusted data sets that have these values of fairness and equity built into them, and then building machine learning models on top of these curated data sets. In the past, it's just been, all right, we're gonna scrape and we're gonna pull it in. But if we really want to solve for this, there needs to be a lot more effort and a lot more professionals working on curating and maintaining the data sets.
All right, we have a question by Yishan Dong. Thanks for the great talk. How would you systematically test to see if there are any biases currently within a company?
So, just to talk about it, that's a very large question, and just to talk about it in terms of one notion of machine learning model fairness within an organization. There are a lot of ways that you can do this. There were some great talks earlier in ODSC East about explainability and interpretability of models. And oftentimes what you want to try to do is look at the outcomes of the model, both in terms of the decision that are happening, but also in terms of your rates of true and or false positives in the mix, and how that breaks down across different demographic groups, and different different facets that might be considered protected. It's a case-by-case basis how you want to go about intervening or measuring whether or not these biases exist. But it's super enlightening to just start by trying to explain model results against these potential features that could be highly correlated with protected classes like race or gender.
Okay, so another question by Mark Anthony. You said that AI struggles with diversity, especially in some minorities, but do you think that segregation between population is necessary in healthcare for better accuracy in predicting diseases?
That's a great question. So there's this notion that your genetic composition informs risks that are in fact different when you look at different health groups. And so you're absolutely right. It's a part of the puzzle here. However, I'd like to challenge that by saying part of the patterns that the model and that healthcare use case I had mentioned earlier at the start of the talk were based off of patterns in access to care. So these individuals had fewer treatments over time, or fewer visits with their primary care physician, for example, over time. And they mapped back to specific zip codes, which is also highly correlated with ethnicity, especially in the US. And this may be a larger problem in the US workforce more so than globally. But that being said, there are aspects of heritage that are important in terms of models, and then there are patterns of care and inequity that are represented in data sets. And it's really up to data science teams to try to understand where it's adding signal and where it is perpetuating bias and amplifying it.
We have another question by Mark Anthony. Say, of course, we like a complex and powerful model, but are we trading complexity for accuracy? Is this hindering us from being able to save more lives?
I think that's a really good point. And just qualitatively, over the past couple of years, every time we've built a model with a client, when we've gotten to a decision trade-off of whether it was more important for them to have a more accurate model or a more transparent, interpretable, explainable model, most of the time the preference is to go for that more explainable approach. Not only because they want to be able to audit it, but also it develops trust in being able to adopt and use the solution. So while the industry for the longest time has been building more accurate, more powerful, more precise models, a big trend that's growing now is taking a step back and saying, you know what, maybe it's okay to sacrifice a few points of accuracy if that helps us understand the model a little bit better, and we can get more value out of it that way.
All right. I don't think we have any more questions. Would you like, we still have 4 minutes. Would you like to say something before we end?
I just want to thank everybody for all the great questions. This was a really fun dialogue. Again, the offer to continue the conversation is extended. If you want to stick around and ask questions after the session, I'll stick around the chat room. But please connect with LinkedIn. And I'm so excited for what you're going to bring back to your organizations to start facilitating the same kinds of conversations. So thank you, everyone.